Hey, I'm going to go over surface area again. And, surface area is a pretty big problem. It's difficult. And a lot of the time, when we're looking at problems that are difficult, many of us, somebody will be there to help us, or maybe somebody will give me and just tell me how to do it. And that's just not the case all the time. And so when I talk about our goal and our mathematical practices today, that's really what I'm getting at, is you have to make sense of the problems that you're dealing with, and not every problem has this simple solution to it that you just like look at it and there's a formula and, oh, I just plug the numbers in, right? Some of these things you have to figure out for yourself, and they're complicated, and that's where we're going to go over surface area again. So the goal today is to solve real world and mathematical problems involving area and surface area of three-dimensional objects. This is the second or third video that I've made discussing this. And then the practices, like I said, we're going to model. I'm going to use modeling. So I'm going to use the pictures. I'm going to represent something mathematically through a drawing. I'm going to use structure. I'm going to take this and transform it into something else, and then have a thought and process and a structure through my problem solving to help me get where I'm going, okay? And then the last thing is make sense of the problem and persevere. Persevere means, we're gonna figure this out. And if you go through the steps that we've gone through, you can figure this out. This isn't something that is above you or so difficult that you can't possibly make sense of it. And so I'm going to go over this first. I am going to put some dimensions here, 6, 15, and 12. So if this thing was 6 inches tall, 15 inches back, and then 12 inches across, this is a three-dimensional object, and it needs 3 dimensions. And here is our length, our width, and our height. And that's all we really need to figure out everything that's going on. Now, we have practiced the idea that every single rectangular prism that we have, and the ones that we built in class, all kind of made this cross shape. So to really make sense of this, what I'm going to do is I'm going to mark each one of these things so that I know which one is which. So like, let's say there's a top and a base, and the base meaning the very bottom. So I'm going to start here with the base. Okay, so the first thing I need to do is figure out the base. I need to find the area of the base. And then what I'm going to do is I'm going to find the area of the base, the area of the top, the right and the left sides, and then the front and the back. And if you look, there's 1, 2, 3, 4, 5, 6 different sides. And if I gave you 6 different numbers, you could add all 6 of them up. I'm sure you could. So all we're going to do is we're going to calculate each of those 6 numbers, knowing that the top and the bottom are the same. So once I figure out the top and the bottom, all I have one of, and then actually I have 2 of the 6 I need. And then I only really have to find the area of 3 different sides. So what I'm going to look at right now is the base. The base of this thing is 12 and then 15. So I'm talking about if this was flat and that base down there, 12 times 15, I've got 12 going across, and then I've got 15 going the other way. Well, 12 times 15. So 12 times 15, if we multiply 12 times 15, we got 0, and that's a 10, 2, 3. And then 1 times 15, so this becomes 180. So the base total is 180, and I'm going to put that in there and circle it. So that's 180, and if the base is 180, the top is also 180, and this is the top over here. And it's also 180, so I'm going to put that over here, and I'm circling the ones that I need to. So I'm creating a structure inside my problem solving to make sense of this later. I'm going to add these 6 things up, and the ones that have been circled are the ones that I'm going to total. Now what I need to do is figure out which one is which. Now it doesn't matter right now which one is which, so I'm going to call this the front, all right? So this piece here in the front, and I'm going to mark this one right here, the front. Whoop. I'm going to mark this one the front, because if I was to take this thing apart and just flat, 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 and just let everything fall down, this one would come down, and that would come down here. Now the front is 12 across, so it's 12 across, and it is 6 tall. Everything that's going this direction is 6. So it's 6. Well, 12 times 6 is, that's 12, and that is 7, is 72. So this is 72. And I'm going to circle it again. And I know that the front and the back are the same. So I'm going to write this one as the back. And then this is 72. So what do I have now? Now I've got the bottom, and I've got the top, and I've got the front and the back. Now I need the right side and the left side. So I'm going to look at the right. The right side is over here, and this is the left. Just like a flat, flat. If it just fell down, if it just fell upon, said this is what it would look like. So here's this side is 15, and then it's 15. That rectangle right there is 15, and it is 6 tall. So this is 15, and this is 6. So area is length times width. So it's 15 times 6. 6 times 5 is 30. 6 times 1, it's 90. So this is 90, and this is 90 as well. And I'm going to circle them. Now what do I need to do? I need to add all of the pieces that I totaled. Now this is the structure in my problem. I've made sense of this because I could put all of 6 pieces of this together. And now what I'm doing is I have modeled this into this shape, and now I'm making sense of it, and I'm persevering, and I am putting structure into the problem-solving process to where I get to the number that I need. Because I'm not looking for one of the sides. I'm not looking for the base. I'm not looking for the right. I'm not looking for the back. I'm looking for the complete surface area of this entire problem. So I've got 180 plus 180 plus, and then I'm going to cross it off because I've counted them already, 180 and 180, and here's a 90. And here's another 90, and then here's a 72, and there's another 72. All right, and now all I have to do is just add them up. Well, 2 plus 2 is 4, and then I don't carry anything, so 8 plus 8 is 16. So I'm going to make a little mark over here. 16 plus 18 plus 14. 6 plus 4 is 10, plus 8 is 18. 1, 2, 3, 4. So this right here is 48. So I'm going to put 8 here, 4, 5, 6. So the square, the area, the surface area on the entire rectangular prism is 684, and it's going to be inches squared because its area. So it's 684 square inches. Every rectangular prism that you come across in your entire life is going to work just like this. Every rectangular prism has 6 sides, and this is how you should calculate the surface area of one of these. This is the basic way. There's another way we can do it, but it's a little more complicated, and I don't want to get into that right now. Okay? So here's that one, and now I want to show you a triangular prism. And it turns out a triangular prism also works the same way every single time. A triangular prism, I'm going to draw, I'll draw the triangular prism here. And then we'll go back like that. And here it is. And then so there's the dotted line in the back, the dotted line over that way, and then the dotted line up front. Okay, so there's a triangular prism that sits back into my board. All right, now what do we need to know? Well, they give us a couple of things here. They give us that 24 is this distance, and then they give us the distance across the front of 30. And then they tell us how tall this triangle is, and that is 8. And then they tell us how long one of the sides is, 17. Now, this one is kind of complicated because not everything's the same all the way around. It's not like this thing is an equilateral. It's not an equilateral triangle and then where all three sides are the same. So this one's going to be a little more complicated. However, there is going to be, if I push the triangles back like this and I just flop with the triangles back, I would have a triangle that looked like this on top of a rectangle, which would again be on top of the other. So I'm going to put, this is my front, so I'm going to write this one front right here. And then if I push that one back, I'm going to call this one my back. And then I'm going to call the bottom, I'm going to call this my base. And then if we opened the sides down like a tent and we just like pull on the sides, then we have a right side and we're going to call the other side the left. Okay. So right and left. So let's start with the base because the base is going to be the easiest piece of this. So the base is going to be 30 wide and 24 long. So this is 24, which means this is 24, this is 24, and this is 24 because they're all the same height, all right, all the same. So 30 times 24, 30 times 24, 0 and 12, and then 60. So this is 720. Here's my 720 on that one. And I circled it because remember, I'm putting structure into my problem solving to when I get to the end, I know what I'm doing, all right? I know where I'm going, I know what I'm looking for, and I have everything that I need to add up at the end. All right, so let's look at the right side. Now the right side is 24, and then one of the sides down here, it's 17. So this is 17, 24 times 17. 24 times 17. So 7 times 4 is 28. 7 times 2, 14, 15, 16. And then 24, so it's 8. See, 408. So this is 408. And you know what that means? If this side is 408, the other side is also 408. Now, my problem with my triangle, I'm going to draw a different triangle over here just so we don't have it on top of that one. Now this is 30 and this is 8 tall. Now every triangle is half of the rectangle that would have been there. So all we have to do is use our formula for our area of our triangle, which is the area of a triangle is 1/2 the base times the height. So here's my base, 30, and then my height is 8. So I'm going to do 30 times 8, which is 0, 20, 240, and then half of that. So divide that by 2, which is 120, and that makes this 120. 120, and that makes this one 120. So now I've got all of the numbers that I need, and I'm going to write them right over here. 720, I'm going to cross that out, and then 408. 408, cross that one out so that I know that I wrote it down. 408, wrote it down, or 120, wrote it down. 120, wrote it down. Add it up. So, get rid of that. Add it up. Now, 1, 2, 3, 4, 5 pieces, 5 numbers. We're looking good. 8 plus 8 is 16. 2, 3, 4, 5, 6, 7. And then 7 plus 8 is 15, 16, 17. 1776. Oh, the history people would love this problem, wouldn't they? Let me check them in my book. Ah, we're right. Good. So 1776. And it is, let's see what my dimensions to begin with were in centimeters. I forgot to tell you that. So centimeters, it is centimeters squared because it's an area, all right? So here's what I did. I looked at my problem and I drew a net that matched it, and then I wrote on my net, look how messy this is, but it's my work, and I was looking for that number. So I found the area of each piece. I marked it so I would remember what it was, and then I started marking them off, added them up, and there's my total, okay? So what I want you to do is I know a lot of you guys are sending me messages like, "Oh, I just don't understand number 5. Well, it looks just like number 3 and 4. It's just a little longer, all right? Or something like that. Persevere through it, try it, look at it, draw it, and work through the problem. I know you got it in you, okay? None of these problems are above you guys, all right? You're all good at this, just work, all right? Just try a little harder. And if you need help, join one of the live sessions and let us know. Thanks.